The shadow loophole, breaking Einstein's speed limit. What if I told you that right now, in your room, there's something moving faster than light? Something that Einstein himself said was impossible. Something that could theoretically race across entire galaxies in seconds, laughing at the cosmic speed limit that's supposed to govern our universe. Welcome to Photon Lab, where we break physics responsibly. I'm PMC, and today we're going to discover how you can become the ultimate cosmic speedster, using nothing more than your smartphone's flashlight and a wall. But first, smash that subscribe button, because what we're about to reveal will completely change how you think about the fastest thing in the universe: the cosmic bouncer. Picture this. The universe is an exclusive nightclub, and Albert Einstein is the bouncer at the door. He's got one golden rule carved in stone, actually carved in space-time itself. Nothing, and I mean absolutely nothing, travels faster than 299,792,458 meters per second. We call this magic number c, the speed of light. It's not just a suggestion, it's the fundamental constant that holds the fabric of causality together. Why is Einstein so strict about this? Because if you break this rule, you don't just break physics, you break time itself. Think about it. If information could travel faster than light, cause and effect would get scrambled. You could receive a text message before it was sent. You could observe an explosion before the bomb was lit. The relationship between cause and effect would be violated because signals could travel backward in time relative to certain reference frames. This isn't just theoretical physics mumbo-jumbo. As physicist Matt O'Dowd explains, the speed of light should really be called the speed of causality. It's the maximum speed at which cause and effect can propagate through space-time. But here's where things get interesting. What if I told you there's a loophole? The Lunar Laser Paradox. Let me blow your mind with a simple thought experiment. Grab your laser pointer. Yes, that little red dot device you use to torment your cat. Point it at the moon, which sits roughly 384,400 kilometers away from Earth. Now, here comes the magic trick. Flick your wrist. Just a tiny movement. Let's say it takes you exactly 0.01 seconds to sweep that laser from one side of the lunar surface to the other. On the moon's surface, that innocent little red dot just traveled approximately 3,474 kilometers. Let's do some quick math here. Distance equals 3,474,000 meters. Time equals 0.01 seconds. Speed equals distance divided by time equals 347,400,000 meters per second. Wait, hold up. That's roughly 347 million meters per second. Light travels at only 299 million meters per second. Did we just watch a red dot casually stroll across the moon at 1.15 times the speed of light? Did your wrist movement just violate Einstein's cosmic law? Before you start planning your Nobel Prize acceptance speech, let's dive deeper. Because what we just witnessed is both absolutely real and completely impossible. The garden hose revelation. Here's where we need to understand the difference between things that exist and things that appear to exist. Imagine you're holding a garden hose, spraying water across your yard. When you swing that hose from left to right, it looks like the stream of water is bending and moving. But here's the key insight. No individual water droplet is actually traveling from the left side of your lawn to the right side. Each drop is still moving outward at its own constant speed. The same principle applies to our lunar laser. That red dot isn't a physical object racing across the moon's surface. It's a sequential arrival of completely different photons. The photons leaving your laser at time t equals 1 hit point A on the moon. Different photons leaving at time t equals 2 hit point B. Think of it like a line of soldiers marching toward a wall. When you rotate the line, different soldiers hit different parts of the wall, but no single soldier runs along the wall. As astrophysicist Michio Kaku explains, just the image of the beam as it races across the night sky is moving faster than light, but there is no message, no net information, no material object that actually moves along this image. So the spot, moving faster than light, is really just where new photons happen to be arriving. Since it has no mass, no energy, and carries no information from point A to point B on the moon, it's not really moving in the physical sense. Enter the shadow realm. Now here's where things get beautifully weird. Let's talk about shadows. A shadow is even more nothing than our laser dot. A shadow is literally the absence of photons. It's where light isn't hitting. It's the ultimate non-thing. But here's the kicker. Shadows follow the exact same geometric rules as our laser spots. If you project a shadow using a nearby lamp onto a distant wall and wag your finger, the shadow will move much faster than your finger, multiplied by the ratio of distances. Let's scale this up to cosmic proportions. Imagine you have a super powerful searchlight. I'm talking Death Star levels of brightness, pointed at a galaxy 100 light years away. Put your hand in front of that light and make a shadow puppet. Now move your hand just slightly. When that light finally reaches the distant galaxy in 100 years, your shadow will be racing across its surface at speeds that make light look like it's standing still. We're talking hundreds, maybe thousands of times faster than light. As science writer Margaret Wertheim puts it, our shadow bat can go 10 times the speed of light, or 100 times faster, without breaking any of physics' sacred rules. Einstein's cosmic bouncer? He's totally fine with this. Why? Because nothing is actually traveling that fast. The shadow is just the absence of information, not the presence of it. The information police. But wait, you clever viewer, I can see the wheels turning in your head. If my shadow can move faster than light, can I use it to send messages to aliens? Imagine you want to send a message to your friend on the moon using shadow Morse code. You decide that shadow appears means dot, and shadow disappears means dash. You start frantically creating patterns faster than light itself. Here's the crucial catch. For your friend to see the shadow appear, the light that was there has to stop arriving. That stop signal still has to travel from your finger on Earth to the moon at exactly the speed of light. Even if your shadow pattern sweeps across the lunar surface at 500 times the speed of light, the information that creates the shadow can't reach any point faster than light can travel from Earth to that point. It's like having a super fast messenger who can only deliver empty envelopes. The envelope arrives quickly, but there's no information inside. This preserves what physicists call causality, the fundamental requirement that cause must precede effect, and that information cannot be transmitted faster than light. Einstein's cosmic speed limit isn't really about light at all. It's about protecting the order of cause and effect in our universe. The experiment you can do right now. Want to break the speed of light right now? Here's your mission. Grab your smartphone's flashlight. Find a wall about 10 feet away. Put your finger in front of the light to create a shadow. Quickly move your finger across the beam. Congratulations! You just made a shadow travel faster than your finger by a factor equal to the wall distance divided by the distance from light to finger. If your wall is 10 times farther from the light than your finger, your shadow moved 10 times faster than your finger moved. Scale this up to astronomical distances, and you've got shadows moving faster than light. As IFL Science notes, this can be achieved by simply waving a laser across the night sky. The spot where it hits a distant surface can exceed light speed. But remember, you're not breaking physics, you're celebrating it. You've just demonstrated one of the universe's most elegant loopholes. The bigger picture. Here's what's truly mind-blowing about all this. Shadows and light spots are some of the only things in the universe that can break the speed limit, precisely because they are nothing. They're the ghosts of physics, patterns that exist in our minds and our measurements, but possess no mass, no energy, and no ability to carry information faster than the photons that create them. The universe has a speed limit not to stop us from moving fast, but to protect the order of cause and effect. And as it turns out, even a shadow, the very definition of nothingness, has to respect the light that defines it. This isn't just a cool party trick. It's a window into the fundamental structure of reality, where information, causality, and space-time itself are all woven together in ways that still amaze physicists today. So the next time someone tells you nothing can go faster than light, you can smile knowingly and say, actually, nothing can go faster than light, because shadows are nothing, and nothings aren't bound by the speed limit of something. If this blew your mind, smash that like button and subscribe to Photon Lab for more physics that will melt your brain in the best possible way. Hit the notification bell so you never miss our latest exploration into the weird and wonderful world of physics. What other impossible things do you want us to explore? Drop your ideas in the comments below, and remember, in physics, the most impossible things are often the most real. Keep questioning, keep exploring, and I'll see you in the next video.